Um, Hi guys. So today we'll be going through basics for encoding. So basically, let's talk about encoding. So encoding is converting an input um, of one data type or one set of characters into another fixed output of a different set of characters. So it's basically transforming one kind of data to other kind of data. So why is it done? So any encoding is basically done to help data to move easily. So for example, it is easy if you want to send an image in form of a text. You need some kind of encoding, right? So there is various purposes of encoding, like for security or to move the data quickly, etc, etc. And today we'll see one method where we basically convert binary data to text. So we can basically do that using base64 encoding. So here binary data is represented as zeros and ones, as you know, and the text that can be converted is ranges from alphabets, both small letters and capital letters, including numbers as well as plus and minus. So here is the encoding table. So you might have asked, you can ask, hey bro, you said that we will be converting binary data to text, but here you're taking decimal values or you're taking numbers. So yeah, actually we do convert binary to text, but the thing is it is not that easy to represent. So basically have converted the binary to decimal, so to easily represent. So this is the decimal value. So basically in place of this we'll have binary data that will convert to these alphabets. So 0 is mapped to A, 1 is mapped to B, similarly Z is mapped to 25 is mapped to Z, and similarly 26 is mapped to small a, 27 is mapped to small b, so on and so forth. And similarly 51 is mapped to 0, 52 is mapped to 1, etc. So we also have one special case which we map using equal to. So I think it's better to go with an example. So before that we'll see the algorithm to convert bits to text. So basically we can convert any data in bits as base64 in okay, so there's kind of type over here. So we can kind of convert any data in bits as base64 deals with the converting binary data to text. So it simply says that we can convert binary data to text. So we first split the data. So we first split the binary data to 24 bits, and again we split the data. So we again split the 24 bits into 6 bits. So one thing to notice is the decimal value of 6 bits lies between 0 to 63, hence the name base64 encoding. Okay, so over this step, if you consider it as 7 bits, then decimal value of the maximum value of 7 bits gonna be 128. So basically you'll get a base 128 encoding, and if you consider 8 bits, it's going to be 256. Okay, that's how it's mapped. So after this, after converting basically dividing into 6 bits, we basically use the map table to find its corresponding character. Okay, so let's see with an example. For example, I have a single letter A. Okay, so I want to convert a character. Okay, the data can be anything, so it can be image. So to convert an image into base64 encoding, first you need to, so since image is in JPG format or PNG format, you first need to convert an image to bits, and then you can then feed the bits to the base64 algorithm, which can convert that to text. So if you want to convert image to base64 encoding, you can do that. Okay. So first, let us start with simple. So I just want to convert a letter. Okay, I want to convert a letter A. So to convert letter A, first we need to convert A to bits. Okay, because base64 it deals with binary data, and to find the binary value of A, we can basically use the ASCII table over here. So if we go, the value of A in ASCII is 41, and if you convert that into bits, it's gonna be this thing. Okay, over here. I think you're familiar with ASCII, so I'm not going in detail. So yeah, and here we get the binary bits for A, and we then need to split into 24 bits. Okay, so you might have observed this. So this input is only 8 bits. So how are we gonna split into 24 bits? Okay, that's the next part, right? So since we don't have enough bits, we can always add some some 0 digit bits to make it 24. Since over here we only have 8 bits, we need to add some 16 bits. So we pad the input with 16 zeros. So now the binary input becomes this. So basically I have padded 16 zeros. Okay. Since our algorithm says that we need to split the binary data into 3 bytes or 24 bits. Okay. So up to now what we have done is we have taken an input can be anything, image or anything. Okay, that we need to properly convert into bits, because in base64 our main algorithm does convert bits to the encoded characters. So we converted the input to bits, and since we need to divide the bits, basically divided the input into 24 bits, we don't have enough bits, we padded some zeros, and then according to the algorithm we need to split the data into 6 bits. So again we are going to split that into 6 bits each. So as you can see on the screen, we now have splitted the input to 6 bits. So this thing is going to be 0 1 0 0, which is of 6 bits, 6 bits, 6 bits. Okay, now we need to convert. So first, so basically base64 encoding, what it does is, so this is the 6 bits, you then convert that to a decimal. Okay, so here you can check the decimal value. So 0100 decimal representation is 16, 0100 I mean 010000 decimal representation is 16, and if you also check this decimal representation, it's 0 0. So then you can go to the base64 encoding table, and you can see that from 0 to 24 it lies in this region, and if you count, the 16 number would be mapped to Q, 16 will map to Q, and 0 is the starting number and it's mapped to A. So now you have 0 mapped to A and 0 mapped to A. So this is the base64 encoded, but as you have seen, we have added some extra zeros to make it 24 bits. We need to remove those bits because we don't want those unnecessary information, right? So what we can do is basically over here what we can do is basically we can remove those extra bits. So we see here these are complete zeros which are converted to A, so we can remove this. Okay, so here remove those A's which are added because of padding, and after that as I said earlier, we have a special case equals to. So to just to help us during the decoding, we can add equal to in place of A's. So it tells that this data is just a padded data, So basically the basics for encoding of A is QQAA. So I hope I kind of gave some info about basics for encoding, and I'm sure you guys have understood it. So this is my first video. Sorry if I am wrong or if I went wrong somewhere. Thank you.